So welcome to the course of flexible AC transmission systems. In the last class we discussed about the various kinds of series compensation techniques. Like the first technique is GCSC, and in that we discussed about GCSC operation and modes of operation and VA characteristics also already seen in the previous class. Today we are going to discuss about the TCSC, that is the thyristor controlled series capacitor. Thyristor controlled series capacitor. What is the name of this one? Thyristor controlled series capacitor. We can control the power flow in the transmission line with the help of the inserting one series capacitor in series with the transmission line. That's what is a series capacitor. The entire series capacitor is connected. What are the, this is the series capacitor transmission line lo series lo ఉంటుంది. Capacitance series lo ఉన్నది, which is connected across the thyristor controlled reactor. We are connecting the one capacitance which is connected across the thyristor controlled reactor, that is the inductance followed by thyristor, that is called, that's why it is a thyristor controller. That means TCR is nothing, TCSC is nothing but fixed capacitor plus thyristor controlled reactor. We can say otherwise. We can ela cheppochu oka capacitance TCR combination, but TCR connected in parallel with the capacitance. Is it okay all of you? So this is the thyristor controlled series capacitor. So by adjusting the by adjusting the turn on angle of this TCR alpha, firing angle of alpha, that turn on angle, by switching on and off of these thyristor valves with the help of alpha, we can control the voltage across the capacitor. For example, if you close these switches, then it acts as a short circuit, therefore it is a inductor, this is short circuit. Suppose if you open the switch, the entire current is passing through these capacitors. If you are closing the switch, then the current is passing through this inductor as well as some capacitor. But if you open the switch, the entire current is passing through these capacitors. Initially we will open the switch, then the transmission current the entire transmission current is allowed to the capacitance. Therefore, it charges the capacitance with a value of Vc initially. After some time, angle changes with the help of the alpha, triggering angle, that means gating pulses changes, automatically ఇక్కడ ఉన్న current అనేది change అవుతుంది reactor లో. Then capacitor voltage may be discharged from maximum to minimum. So this the main thing in the TCSC, thyristor controlled series capacitor. Here the thyristor controlled series capacitor it is a series controlled capacitive reactance. It is a series controlled capacitive reactance. Thyristor controlled series capacitor ఏమంటారంటే it is a series controlled. We can control this series controlled capacitive reactance. ఈ capacitive reactance XC వాల్యూని control చేస్తున్నాం with the help of this thyristor valves. We are not using any GTOs. We are using the thyristors. We can control the capacitive reactance, series capacitor reactance with the help of the thyristor controlled reactor. That's what is called as series controlled capacitive reactance. Is it clear, all of you? So now let us go to the brief discussion over this TCSC. We know that it is a capacitance change చేస్తున్నాం కాబట్టి capacitance లో voltage కి current relation ఎలా ఉంటుంది? The current is always leading with the voltage. That's why this is the voltage across the capacitor, this is the current. Always if you observe that this is the voltage starting positive cycle, but current here is starting. అంటే ఏమవుతుంది? Current always lead with respect to voltage in the capacitance, which I have observed in the basic theory of networks. Now here I am using that where XL is the reactance of this TCR branch. For example, this is the XL is the inductive reactance, but this inductive reactance as a function of which based on the thyristors. If the thyristors are open, not including the reactance. If the thyristors are closed, then it is acted as short circuit. Therefore, inductor is connected to here in this fashion, and the shunt lo connect chesi untundi. So this is as a function of alpha. This is called XL omega. Generally, with the inductive reactance, XL is equal to omega L, but it is a function of alpha XL of. But what is the reactance? Capacitive reactance X is equal to 1 by omega C. This is the. Here we can change the capacitive reactance with the help of the inductive reactance, which in turn depends upon the alpha. By changing the alpha thyristor switching on and off positions, then we can change the inductive reactance, then we can change the capacitance. Because if voltage changes, it automatically change. So here the basic principle is, by changing the alpha, we can change the XL, because we can change the capacitance. So what the relation between alpha and XL? So we know that. So before going to discuss about this point, let us go through this derivation. So under steady state conditions, if you neglect the losses of the switches and everything in the transmission losses, then TCSC, that is the reactance, total reactance TCSC, but alpha, because of the one of the function of this capacitance or reactor, ఇందులో capacitance and reactor చూసుకుంటే reactor అనేది alpha మీద base అవుతుంది కాబట్టి entire TCSC depends upon the alpha as a function of alpha. Therefore, both two are XC and XL, both are connected in parallel, but XL is a function of alpha. Therefore, XC into XL alpha by XL minus XC. This is the total reactance offered by the circuit. But what is XL of alpha? We can derive this. We know that we derive chadam kuda. So here, what is the voltage across the? Sorry, this is the thyristor control reactor. This thyristor control reactor is like a shunt connected device. What is the reference of the shunt connected device? Current is the reference. Sorry, voltage is the reference. Current is controllable. Current ni control చేస్తాం by giving input voltage, maintain constant. Voltage ఇచ్చి current కంట్రోల్ చేస్తాం. అదే థైరిస్టర్ మనకి సిరీస్ కంపన్సేషన్ ఏం చేస్తాం? కరెంట్ ఇచ్చి వోల్టేజ్ కంట్రోల్ చేస్తాం. సో హియర్ దిస్ ఇస్ ద TCR. We know that in the TCR, thyristor control reactor, the IL, the current through this reactive element, is as a function of alpha, IL of alpha. That means that whenever the thyristor is on, the inductive current as a function of alpha, IL of alpha, is equal to the reference is voltage by reactance omega L into 1 minus 2 by pi alpha, not gamma, minus, I will erase here, alpha minus 1 by pi sine 2 alpha. This is the amount of reactive current, so amount of inductor current flowing through this reactor whenever the TCR is operating condition. I am talking about the bottom of the circuit, alpha. This can be observed in the previous class in the unit 4. So V by omega 1 by minus 2 by pi XL. From this, what is XL of alpha? X is equal to V by IL of alpha. Substitute IL of alpha in this equation. ఈ ఈక్వేషన్ సబ్స్టిట్యూట్ చేస్తే ఏమవుతుంది? సో ఇక్కడ V ఉంది, ఇక్కడ V ఉంది. Again V cancelled. Only we are having 1 by omega L into 1 minus 2 by pi alpha minus 1 by pi into sine 2 alpha. But again omega L is ఇక్కడ V by omega L. So omega L పైకి వెళ్ళిపోతుంది కాబట్టి, so this is omega L. Substitute IL of alpha in this equation into V by IL of alpha. ఈ IL of alpha ప్లేస్ లో ఈ ఈక్వేషన్ సబ్స్టిట్యూట్ చేస్తే పోతుంది. V by omega, V cancel అయిపోతే omega L పైకి వెళ్ళిపోతుంది. is into the denominator omega L by 1 minus 2 by pi alpha minus 1 by pi into sine 2 alpha. From this, what is omega L here? We can write as XL, because of initially you taken as XL is equal to omega L, but as a function of alpha it can be changed. But initially XL is equal to omega L only, without any considering a reactance. Therefore omega L can be replaced with XL and take pi ని ఇక్కడ సింప్లిఫికేషన్ చేయండి. డినామినేటర్ లో పై ఉంది కాబట్టి pi minus 2 alpha minus sine 2 alpha into pi పైకి వెళ్ళిపోతుంది into 5. Therefore, from this conclusion you can observe that the inductive reactance is a function of alpha, which depends upon the XL into pi by pi minus 2 alpha minus sine 2 alpha. So we can in that equation we can determine the what is the maximum value of alpha So why the maximum value of inductive reactance and minimum value of inductive reactance. ఈ ఈక్వేషన్ నుంచి మన XL of alpha అనేది ఏమవుతుంది, XL into pi minus 2 alpha minus sin 2 alpha. Then we can determine the minimum value of reactance as well as the maximum value of reactance. Okay. So from this we can determine that the XL value in the range of between XL to infinity. This is the minimum inductive reactance. This is the maximum inductive reactance based on the alpha. Put alpha equal to 0, something having XL. If alpha equal to some angle, we can get the maximum value. So this is the range of inductive reactance in the TCR from minimum to maximum here. Similarly, we can choose that the capacitive reactance XC minimum is equal to 1 by omega C, but XC maximum is almost infinity, like in XL. It is the minimum is 1 by 1 omega C, maximum is infinity. Because of the capacitance is fixed one, there is no concept of alpha here. Therefore, either having 1 by omega C or mu omega. అంటే ఓపెన్ అయ్యింది అనుకోండి, ఒకసారి ఓపెన్ అవుతే కెపాసిటర్ ఓపెన్ అవుతే ఇన్ఫినిటీ, ఓపెన్ సర్క్యూట్ ఇన్ఫినిటీ రియాక్టెన్స్, షార్ట్ అయితే 1 omega C. So not having any other values, 1 omega C or infinity. From this we can conclude that what the IC current, IC is equal to capital I plus IL of alpha. That means the current through the capacitance, is depends upon the I plus IL of alpha. That is the inductive nature of current. Reactance, ఈ reactance ఉన్న current మీద depend అవుతుంది. Each in turn depends upon the alpha. By adjusting the alpha thyristors, the current through the inductive reactance it changes. Therefore, the capacitance current changes. Therefore, capacitance voltage changes. We can also observe that fundamental concept of capacitor. The voltage polarity of the capacitor and the current polarity always opposite. Voltage in this direction, capacitance current is in this direction. It is towards left side, it is towards right side here in this circuit. So the capacitance currents and capacitance voltage are opposite, as similar. And also we can observe that the capacitance current and inductor current also in the capacitor voltage and inductor current also in the opposite direction as per the circuit. But ఇండివిజువల్ గా మాట్లాడుకుంటే కెపాసిటర్ కరెంట్ కెపాసిటర్ వోల్టేజ్ ఎప్పుడు కూడా ఆపోజిట్ లో ఉంటాయి. సో దిస్ ఇస్ అబౌట్ importance of the thyristor control series capacitors. In the next class we are going to see the different modes of operation of the TCSC.